Well, hello, Econ students, and welcome back. Today, we are going to be looking at one of the first fundamental graphs that we look at in both micro and if you were doing macroeconomics, you would still be learning this as well. There is a lot, as I may have mentioned, of graphing in econ and a lot of different graphs and models that you need to be able to know how to read, how to draw, how to utilize, all those kind of things. And the one we're going to talk about today is always the first one. This is the first essential graph and model that you need to understand that illustrates and shows us some of the very concepts that we talked about in the first section, like scarcity and those kind of things. And this is something called the production possibilities curve, or the PPC. Today we're going to learn what that means, what it shows, how we read one, how we might draw one, and we'll get a little practice doing that as well. So let's get started taking a look, first of all, just defining what the PPC is and getting a bit of an idea of what one looks like and all of that. And unfortunately, I see now my face is going to cover up some of the graphs, but we will work through that here in a minute. So we talked in the previous section about what economics is, and that economics is the study of and the analyzation of how we make choices about how we're going to allocate scarce resources amongst unlimited ones. We can't have everything that we want. We don't have enough resources to produce everything that we want. So how do we make those decisions? And one of the models that economists use to study that very thing, that helps us think about those opportunity costs. Opportunity costs, very, very important here. That's always going to be important. Remember, opportunity cost is the cost of not the same thing as price, but what has to be given up in order to gain more of something. We're going to see all that illustrated here in just a moment. But this model helps economists see those things and think about those trade-offs and those opportunity costs. And that is the production possibilities curve. You may also sometimes see it called the production possibilities frontier. I think you're going to see it way more often as the production possibilities curve. I really haven't seen it as frontier too much. And you will also hear and see that abbreviated PPC. So make sure you know what a PPC is. It is a production possibilities curve. And before I go into exactly what you're seeing here, this right here, there, is pretty much what a PPC is going to look like most of the time. Notice we have our x-axis and our y-axis, and then it makes a curve down like so. And they are usually bowed out like that. I'm going to explain all about that here in just a moment. Sometimes you will see one that just makes a nice, perfect linear curve there. But usually they're going to be bowed out, and there's a reason for that. And we need to understand what that is. But let's talk about what the PPC does. The PPC is a model, and in econ we use models. That's what we use, is models, examples, little microcosms to explain bigger concepts. It is a model that displays the maximum quantity of two goods that a country, a firm, whatever you want to call it, could produce. So again, it's a model. So in these, we assume that a country or a nation, a company, whatever, a person, it could be an individual person as well, whoever the PPC represents, that they can only produce or can only do two things. Again, these are models. They're theoretical fictions. In the real world, I don't think we would imagine a country that can only produce two things. But this, again, it's a model that helps us understand the bigger picture. But anyway, it shows us, it displays for us, it's a graphical representation of the maximum quantity of two different goods that could be produced. And it shows us, it illustrates the different combinations of goods or services they could produce. In other words, it shows that we can produce all of this and none of this, or all of this and none of that, or we produce somewhere in between. And as you can imagine, most countries are going to produce somewhere in between. So it shows us the trade-offs. Now that's very, very similar to opportunity cost. The trade-off, is what you have to give up. If you're going to produce more of good A, you're definitely going to have to produce less of good B. And that's your part of the opportunity cost. And so, we don't call it opportunity cost in this case because it doesn't include all parts of the opportunity cost, but it's showing particularly what other goods have to be given up in order to do that. If you're going to spend more hours, playing a video game, that means you have to give up some hours that you could have used, going to McDonald's or something. I don't know. You have to give something up. Those are the trade-offs, and a PPC helps us see those things. So let me go over with you what you're seeing here as best I can. I realize now my videos covering up part of that. I'll remember that next time to make sure that's not going to happen. Okay, so this shows in this particular made-up country, made-up situation, in this PPC, it's showing that they can produce the possibility of two goods. They can either produce pizza. I'm going to put up my laser pointer here, maybe, if I can find it. Yeah, laser pointer. Here we go. Okay, so pizza is one good they can produce, or sugar. Again, doesn't really make sense in the real world. Kind of doubtful there'd be a country that could only produce pizza and only produce sugar and all that stuff. So they can produce, this is the y-axis here is showing the amount of pizza they could produce, and the x-axis is showing the amount of sugar they could possibly produce. So if they're producing way up here on pizza, let's say this is 10 million pizzas, that would mean they're producing no sugar. If they're way over here producing, let's say, 10 million pounds of sugar, that would mean they are producing no pizza, because you see they're all the way down there on 0. This right here, this is the PPC. Notice it's bowed out nature and these different points that are labeled on it. This shows us those different combinations. It's probably more likely that they're not going to produce, all pizza and no sugar. They're going to produce some of one and some of the other. So say, for example, at point B, again, I don't have numbers here on my axes to give me specifics, but let's just assume here at point B, maybe that's I can produce 9 million pizzas and maybe 5 million pounds of sugar. Maybe I want to move over here to point A, meaning I'm going to produce more sugar. Maybe that's 8 million pounds of sugar, but that means I'm only going to produce 6 million pizzas. I could go to point C, so forth and so on. Now, and A is when you can't, here's A. Okay, these are efficient, A, B, and C right here. Notice that they are right along the curve. So they are efficient output combinations. If the country or the nation, whoever this is, if they are producing anywhere on this curve, which would be points A, B, and C, and any others that I might choose to label along this blue line that I keep going over, that means that they are totally efficient. That means that they are utilizing all of their resources as best they can. We're going to further define efficiency here in just a little bit. Now, you may be wondering, well, what are all these other points that are labeled to the inside and the outside? D and E here, these represent points, and anything else, not just D and E, but any other dot that I might want to place inside this curve, underneath it, those represent inefficiency. Those are combinations. If they're right here producing whatever number of pizza this is and whatever number of sugar this is, they can do that. They have the resources to do that, but they'd be inefficient because they could be producing over here or over there. They could be producing more. So it is possible, but it's not efficient. It means that they're not utilizing all of their resources. Maybe they're not employing all of their workforce. Maybe they've got factories that they've got shuttered. Perhaps they're in the middle of an economic recession, and that's the reason for that. Now, F over here, or anything else that I might want to label outside of this curve, that is unobtainable. Okay, that's not possible. That is an output combination that they can't get to because they don't have the resources for that. They cannot possibly produce here unless they were able to somehow move this curve out by perhaps developing new technology or something like that. We'll get to in just a moment the things that might cause that PPC to actually move, not just to shift, not just move along it, but to shift somewhere else. But the PPC, again, it shows us scarcity. We see here that they can't produce just an unlimited amount of pizza. They can't just produce an unlimited amount of sugar. They only have enough resources to do something in here. Okay, so it's showing us scarcity. It shows us the trade-offs. We could see, and particularly if we had numbers, and we'll look at some in a moment that have numbers, we could see exactly how many pizzas are they going to have to give up if they want to increase to a certain point of sugar. So it shows us those trade-offs. It shows us that opportunity cost. Okay, so now I want to show you another example. Now this one, you'll notice, looks a little bit different. This one's perfectly linear. Okay, see how the line is perfectly linear? It doesn't bow out like that. Most of the time that's not the case. Most of the ones you see, I think, are going to be the bowed out ones, but you do need to be able to recognize the difference there and what difference that is showing you. And actually, I'm going to tell you that in a moment. We'll come back to this one and show you that. But let's take a look again. This one has numbers, okay? So we can look more specifically at what some of those opportunity costs and trade-offs are. So this one comes from, this is an example of, let's say somebody's stranded on the desert island and they can produce, or they can gather coconuts, or they can catch fish. So this is their production possibilities curve showing all the different possible combinations of coconuts and fish that they can produce, okay? If they were, let me get my laser pointer back, because I think that's a little easier to see. They can produce as many as 30 coconuts. But if they were producing 30 coconuts, they wouldn't be producing any fish. They could produce as many fish. If they put all their resources toward catching fish, they could catch 40 in, let's say this is a day, whatever time frame this is representing. But that would, of course, mean that they're not producing any coconuts. They're not gathering any of those because they're using all their time and their resources to catch fish. So more likely, they're probably going to be somewhere along here. If they decide to produce at point A, that means that they are gathering 15 coconuts and 20 fish. If they decide maybe they want more fish, they want 28 instead, well, they can do that. They can catch 20 fish, but that means they're only going to be able to get 9 coconuts. Okay, so you see, there's your opportunity cost. C, that means they're producing 9 coconuts and 20 fish. They can do that, but again, that is inefficient because they could be producing here or there. They could be getting more. This would be, inefficient. D is unobtainable because they don't have the capacity, they don't have the resources to produce there. So let's see all that again. So again, C, feasible, but not efficient. They're not utilizing all of their resources. Anywhere along the curve itself is feasible and it's efficient. It means that they're utilizing all of their resources the best way that they can. Nothing is wasted. But if we wanted to be at D, that's not feasible. He would have to, I guess we're considering this example as an individual person. He'd have to improve his skills and get better at fishing, or maybe he gets a net or a bigger net or something like that. That'd be new technology. Maybe he could get to that particular point. Okay, now, I keep going back to that word efficiency. I keep using that word. And that's a word I think you're probably pretty familiar with. You use it quite a lot. It does have maybe a little bit of a more specific definition when it comes to economics. When you talk about being efficient, efficient with your time, efficient with whatever, you mean that you're using it to the best of your ability. You're not wasting your time. You're not wasting your energy. You're not wasting your resources. And that's pretty much the same thing that it means when it comes to economics. It means that there are no missed opportunities. There are no missed opportunities to produce something. There are no missed opportunities to consume something. There's not another situation where you would be better off. And every point on these PPCs, if you're on it, on that curve somewhere, it's efficient. It means that they are using their resources the best way they can. They're utilizing all resources, and nobody could be made better off without making somebody else worse off. Now, there's actually 2 different kinds of efficiency. This is where the definition starts to get much more specific when dealing with economics. There is something called productive efficiency and there's allocative efficiency. We're going to barely hit on these topics right now, but later on in the course, we will talk more about productive and allocative efficiency, and you'll learn more about more specific ways to find those answers about what's productively efficient and allocatively efficient. But for right now, we'll say productive efficiency. That's on the production side. If a company, a nation, or whatever is productively efficient, that means that they are utilizing all of their resources in the best way that they can. They're not choosing not to employ people that could be working. They're not choosing to not utilize factories or capital that they could. So productive efficiency is when they are producing somewhere on that PPC. And as long as they're somewhere on that PPC, they are productively efficient. That may or may not mean they're what's called allocatively efficient. Allocative, to allocate something means to give it out. Allocative efficiency means that they're producing the combination of things that society wants, that they are giving society what they want. Let's say, if we go back to that pizza and sugar example, if they were making all the pizzas they could and no sugar, that's productively efficient. We saw that's a spot on their PPC. They are productively efficient if they choose to do that, but that may not be allocatively efficient, because if they're not producing any sugar, then nobody has any sugar. And it's quite possible that people want and need sugar. So that would not be a situation where society is best off. So think of productive efficiency as where your producers are kind of better off, but allocative efficiency more relates to the consumer producing what society wants. And the challenge in economics is to find that balancing point. Where are you both? And there's plenty of both productively and allocatively efficient. And we'll talk later about different market structures that can produce both of those, and certain market structure that produce neither of them or one or the other. So again, we'll look more at that as time goes along. Now, let me go back to a point I made a little bit earlier, and that was the shape of the production possibilities curve. The first one that we looked at, and the one that, like I said, I think you'll see this one most often, and that's with the bowed out shape, with the shape that, oops, I went backwards. Here we go. The one that looks, let me show you. And forgive my writing. It's hard to write on a PowerPoint with a mouse, especially when you're left-handed. So this might be a little crazy. The bowed out one, of course, like that. And then you have the totally linear ones, something like that. And we've seen both. The reason for the bowed out shape for this one right here, and again, this is the kind you're going to see most of the time, that is illustrating something called the law of increasing opportunity cost. Okay, the law of increasing opportunity cost. What that means is the more you make of one thing, the opportunity cost of, the other thing, the opportunity cost of that goes up. Okay, that the more you make of good A, the opportunity cost of that increases. The more you make of good A, the more of good B you have to give up. The more pizza you produce, the more sugar you have to give up. The more, what was another example we saw? Coconuts that you gather, the more fish you're going to have to give up. It increases. My opportunity cost of going from A to B might only be 5 units of this. Once I go to B to C, now it might be 15 or 20, that it gets greater as time goes along. The reason for that, why we have that law of increasing opportunity cost, and that's being shown by that bowed out shape right there that I just drew so majestically, is because not all resources are the same. This means, not all resources are well suited to everything. Not all workers, let's go back to the pizza and the sugar example. And if I'm going to start producing more pizzas, I got to take more people that might have been producing sugar to produce pizzas. Well, those people might be better suited to growing sugar. They may not be very good at baking pizza. So they're not going to be as efficient workers. The cost of that goes up, and the resources to make the pizzas are going to become more and more expensive as we have to use more and more of them because they are scarce. And so the opportunity cost of that increases. Now this one over here with the linear one, this illustrates what we would call constant opportunity cost. There you are assuming that all resources are equal. Again, it's a theoretical fiction because in reality that wouldn't actually be the case. But in this case, the opportunity cost of moving from one point to another point is the same every single time. Whereas what we'll see here is, notice if I, move up a little bit, I'm giving, to increase more of what I'm producing, whatever it does on this axis. Let's say it was pizza. I'm not really giving up all that much sugar. But notice as I increase that, how much further it's moving along that x-axis. I'm having to utilize more of my resources that were better suited to producing sugar, and therefore that opportunity cost goes up. So this is why it's usually not linear. This is why it's usually bowed out. It is showing that increasing opportunity cost. Now let's see that again with some much better drawings than the ones that I just did. So this is going back to our coconuts and fish example, but this one is showing increasing opportunity costs. I know that it's showing increasing opportunity costs because of this bowed out shape like this. Now, let's say that we could be producing right here where we're producing 30 coconuts and 0 fish. Well, I don't want to do that. Let's say we're producing point A. Now that means that I'm producing 25 coconuts and I can catch 20 fish. All right. Now let's say that they decide they want to produce, there's my cute background. So producing the first 20 fish, when I go from 30, 30 coconuts means I was producing no fish. All right. We decide we want to produce some fish. So we're going to do 20 fish. All right. So now we're going to move from there to here. That means that I can't produce 30 coconuts anymore. I can only produce 25. So my opportunity cost was 5 of those coconuts. Okay, that requires I have to give up 5 coconuts. That was my opportunity cost. So I produced 20 additional fish. That cost me 5 coconuts. Okay, so that's what we mean by distributing opportunity costs, and that's how you can calculate opportunity costs using a PPC. Now let's say we want to move, we're going to produce another 20 fish. Okay, we want another 20 fish. We don't, because it's bowed out like this, that means that the opportunity cost of that is not going to be another 5 coconuts. It's going to be way more than that. Let's take a look. So if I want to go from, I was producing 20, now I want to go to 40. All right. Well, that's going to mean that I can't produce any coconuts. So I've gone from producing 25 to none. So that means I had to give up 25 coconuts. So if I produce the next 20, that means 25 coconuts. So the first 20 fish that I produced cost me 5 coconuts. The next 20 was 25. That's increasing opportunity costs because, again, not all resources are the same, but that's the reason for the bowed out shape. The first one, that was linear, that was constant opportunity cost. In that case, it would have been 5 or 20, whatever it was, every time. Every time I produced an additional coconut, it cost me additional fish, and so forth. It just kept going. But usually, like I said, it's going to be bowed out like this. Now, let's talk about, it's important that we understand the difference between, and actually I'm going to go back a second to better illustrate this. The difference between movement along the PPC and then the actual shift of the PPC. Movement along the PPC means I'm staying on this. Maybe I'm producing less coconuts or less fish or more, whatever, but I'm still on my PPC. That is movement along. It is not a shift. A shift of the PPC means that it actually moves. It relocates either here, or gets smaller. Even if I was producing, in one of these spots right here, I'm still, I'm inefficient, but the PPC itself did not shift. The PPC itself is in the same place, even if I'm inefficient. We need to talk about what would actually shift it, not cause movement along it, but shift it, either bow it out even further or cause it to shrink in. So that's what I want to talk about next. Oh, not laser pointer. There we go. Okay, so that has to do with economic growth, or it could also be, if you're going inside, it could be economic retraction, economic shrinking. All right, so what actually shifts it? Again, what we mean by shifting it, actually moving it over or moving it under. Economic growth can do that when the economy expands because there are more businesses. When the economy expands, when there are more industries, more people to employ, all those kind of things, that would mean economic growth. It can also happen because, and this would be contributing to economic growth, it's all kind of related, an increase in resources. Say we find a new resource that we can use, or somehow, we find a new way to produce something. More labor, if there was a population increase, if there was an immigration surge, anything like that would actually not cause you to move to a different spot on your PPC, but actually cause it to bow out, to shift completely. Let's say there was new education and people are, more efficient. There's new training, new skills that are acquired. That could actually shift your PPC. That goes along with new technology. So any kind of increase in resources, we've discovered, that this mineral that we thought was worthless can be used to power, rocket ships or something like that. We developed a new machinery. We got more productively efficient. We got better training for our workers so they can produce more. All of those things would cause it to shift out. As far as shifting in, again, some of the stuff you would probably think would shift it toward the inside are probably just moving you to a point of inefficiency. For example, unemployment. If there's high unemployment, the PPC did not move. If there was high unemployment, you just went to one of those points inside it that was inefficient because those workers are still there. It's just they're not being utilized. But let's say there was some kind of big national disaster or natural disaster, some kind of calamity, and 100,000 people didn't survive it. Well, that would shift it in. That would mean that those people are no longer present. They're no longer there. So there's the same difference as, say, I have factories that are just shuttered right now because we're not using them because we're in some kind of economic recession. That doesn't move the PPC. It just moves you to one of those inefficient points. But let's say there's a hurricane and all those factories got destroyed. That would actually shift it inward. So that same kind of a thing there. Make sure you know the difference between what moves you to another point along it or just moves you inside it or outside it, and then what actually moves it completely, causes it to shift in or to shift out. All right, now what I want to do is we're going to run through, I've got two little practice problems here. And the first one I thought we would run through together. And again, I'm realizing my face is going to cover up some of this. So I apologize for that. And then I've got the next one, what I'd like for you to do there is actually pause the video, see if you can work out the answers yourself, and then start it again to check and see if you got it right. So here's our PPC for Switzerland. They can produce chocolate or watches. And it's always fun to see what kind of examples people come up with, because they always kind of make it crazy of like two things that they can produce, like shovels and marshmallows or something weird like that. Okay, so first, our first question is to identify the points on the PPC that represent efficient use of their resources. So that would be anything along the curve itself. So that would be A, B, C, or D. Any of those things would be efficient use of their resources. The points that represent inefficient use of their resources, well, that would be X and Y, because they could produce in those points, but they wouldn't be efficient. They're not utilizing all of their resources as best they can there. So that'd be X and Y. Now, calculate the opportunity cost of moving from point A to point B. Now, this one does have numbers, and it's not real exact, so we're going to be doing some approximations here. So let's say if we want to move from point A to point B. Well, at point A, we are producing, I guess this is 8 million bars of chocolate and no watches. And if we move at point B, we're like at about 7.5 million bars of chocolate and 3 watches. Okay, so the difference there, in order to produce more watches, is I had to go from 8 million bars of chocolate to what looks like about 7.5. So I'm going to say about 500,000 bars of chocolate. That's the difference in the chocolate bars between point A and point B. So that's what I had to give up in order to gain those 3,000 watches. How about point B to point C? Well, we said we were at about 7.5 million bars of chocolate here. This, we'll call that 6.5 million. Again, it's a little bit higher than that, but 6.5 million in order to go from 3,000 watches to 6,000 watches. So that is a difference of approximately 1 million chocolate bars. So notice again, we increased the number of watches by 3,000 each time, but notice that the opportunity cost increased, increasing opportunity cost. That's why it's bowed out like that. All resources not the same. If we go from C to D, well, there's a pretty big jump. We're going to go from 6 now to 9,000 watches, but we go from about 6.5 million or so million bars of chocolate to none. So it's about an opportunity cost of about 6.5 million chocolate bars. Once again, notice the movement for watches, we were going up by 3,000 each time, but the opportunity cost went from 500,000 to 1 million to 6.5 million, increasing opportunity cost. It gets more as you go along. Now let's go backwards, point C to point B. That means we're going to produce more chocolate bars. Okay, well, the opportunity cost there, I can produce 6 watches here. I can only produce 3 here, so it would be 3,000 watches. Okay, now explaining the bowed out shape of the PPC. Again, that is showing the increasing opportunity costs and how the more we produce of one thing, the more we have to give up of another, again, because not all resources are created equal. What would be necessary for Switzerland to move to point Z? This is unobtainable at this point. So in other words, they need to have some kind of economic growth. They might need new technology. They might need a population increase, better education, something that could cause them to actually move this out to where that would actually be a point on it. So hopefully that makes sense. And there goes the intercom.
Coach Coleman, please call the main office. Coach Coleman, please call the main office.
It's just like being in school, isn't it? Okay, so now what I'd like for you to do is go ahead and pause this video for a moment and answer, don't pause it yet, these questions, I think. Yes. Okay, so pause the video, answer those questions on a scratch sheet of paper, and then hit play when you're ready to see if you got it right. So assuming now that you did pause the video, I hope you did, you got to learn by doing in this class. So make sure you're always taking that opportunity to get some practice. Okay, so this one, first of all, let's point out, this one is linear. So this one is not showing increasing opportunity costs. This one is showing constant opportunity costs. And we'll see that here with the calculations that you hopefully just did. So moving from point B to point C, this is wall clocks and wristwatches. So we could produce 18 wall clocks if we're producing 3 wrist watches. But if we go to 6, now we can only produce 9. So that means that the answer was it cost 9 wall clocks. The next one is also 9 as we go from C to D, because we're going from 9 wall clocks down to none. And if we go from C to A, there we're wanting to produce more wall clocks. Well, that should say wristwatches right there. There's a mistake. And by the time you see this, I'll already have corrected it. So that should be 18 wristwatches. Note the PPC, how does this demonstrate the basic economic problem? Well, it's a couple of things. It shows that their resources are limited. It shows that they cannot produce everything. They can't produce, if they produce 27 wall clocks, well, then they can't produce any wristwatches, those kinds of things. It shows that every economic decision has opportunity costs, and it demonstrates that for us. So hopefully you'll get a chance to do some more practice with the PPC. Again, this is the first fundamental and basic graph that you'll learn, and it's very important, discard those, to make sure you understand how to read those, how to draw them. We'll do some practice later with actually drawing your own, but it's pretty much as simple as drawing a bowed outline or a linear kind of a graph. So next time we will gather and we will take a look at looking at trade and how countries can interact with each other to make themselves better off. So until next time, practice those PPCs, and we'll see you then.